Hello all. Let us try to understand what Istio is, what a service mesh is, and what is the problem that it is solving, and why do we need something called as Istio. So to understand this, we need to basically get into monoliths, and then we need to basically think of microservices. And then once we understand the microservices, then we need to understand what are the challenges that microservices pose or add to in your system, and how can a service mesh like Istio solve the problem. So let us get started. So I'll try to make a notes of it so that you can basically look into this once the class is done. So first let us try to understand what this monolith applications are. So this is a very popular way of basically deploying your application, and this is still in use, but let us try to understand what a monolith is. Assume that you are developing an application. Let us assume that that application is an insurance management system. So what your developers do is, okay, application development, okay, or let me put it in this way. First let me try to represent it in pictorially. Right, sir. So you have your developers developing your application called as insurance management system. Okay. So for this system, they would have some kind of a database. Okay. And whenever users access your insurance management system, it will try to interact with this database to store the necessary contents into database. Now, here all of your insurance management logic is basically deployed onto one host. Okay. So this is a very simple deployment, right? And many organizations follow this kind of a standard. Now in this case what happens is all of your application is basically deployed as one single package. So when I say package, it could be a war file, it could be a .NET's DLL and all of that stuff. So in addition to that, when multiple developers are developing for this whole insurance management system, I'll write mgmt system, you will have one code base. So all of your developers are writing code to the same repository. Okay. So we have same platform or programming language used. So whole throughout the insurance management system, you might be basically going with a programming language such as Java or Python or whatever it is. So we will have a database. Okay. So all of your insurance management will use one database. That one database could be a SQL server, or could be an Oracle database, or MySQL, or MongoDB, whatever it is. For the whole application, you have this stuff. So when you start building applications like this, or any application, even microservices patterns recommend you building applications in a monolith fashion first. So let me try to take a screen capture of this. Okay. So as you add lot of features to this, as you start adding lot of features to it, this monolith becomes slightly complicated. Okay. But at its core, it is very simple, because you have one repository, you have one way of deploying your application, and 1 minute, sir. Right. So consider a simple application. So as and when we progress building this application, what happens basically is it becomes simple. But as application grows and developers or multiple developers start adding features, okay, all of the developers are using one code base. Now your developers add lot of features, right? So at this point what happens is the complexity of this application becomes very difficult. Okay, so some of the challenges which we have is, okay, even a small change in the code might lead to deployment, which means downtime. Okay, because even if you want to deploy a smallest possible part in this insurance management system, you have to deploy this whole insurance management systems package. That is the first challenge. And scaling becomes one more overhead. So even whole of your application is not widely used by your customers, but if you, in the cases of to meet the demands, for example, if you take any web server, so for let me take an example of Apache server. If you try to deploy this application somehow on an Apache server, it can parallelly take up to 10,000 requests. Okay, so if your user base is more than that, then you have to increase number of servers. When you increase number of servers, then basically what happens, you would have multiple insurance management hosts and all of them speaking to the database. And in your insurance management system, it might not be necessary that all parts of your systems are basically in use. There might be only you might have done some PR activity. Due to that, you are creating a lot of estimates, so only the estimate module is might be in load, but you are scaling the whole system. You are scaling the whole system. So at this point, rather than looking at a system like one beast, people have started looking at systems like microservices. But before we go to microservices, there is one misconception which I want to clear. Okay, generally microservice will have its own DB, and its own code base. One popular what do you call, one popular approach which people try to take is, if microservice is not working, it should be very easy to replace, or it should be, they will, there is a term which people refer, they try to tell that microservices should be very simple. Okay, and each microservice should be depicting some business capability, and if that microservices is are of if that particular microservice is not working correctly, you should be in a situation to throw it away and write the new one. So typically your microservice might have code in the terms of hundreds of lines, not more than that. Okay, generally. Okay, so each microservice is a functionality which can be individually deployed. Okay, so that is basically what a microservice is. But over here there is some misconception. Okay, so in the architecture we have something called as distributed monolith. Okay, so some organizations or some design is according to this. So what is this distributed monolith? In distributed monolith, what organizations do is, okay, they try to tell that, okay, I don't want to have one service. To run my application, I have 3 or 4 different services. Okay, all of this use the same database. Okay, so this could be your service 1, this could be your service 2, this could be your service 3, and this could be your service. Now all your applications are using the same database. Okay, you cannot call this as a microservice, because if you understood the microservice correctly, we have said that each microservice first of all should be small, and the second thing is each microservice should be having its own database. But in this case, what is happening? You are having a shared database. Now the problem with this kind of approach is, when you make some change, anywhere in the system, the other service also might be impacted. This kind of an architecture is called as a distributed monolith. The problem with this kind of an architecture is, it has disadvantages of both, or it has complexities of both monolith and microservices. Okay, so here I'm just going to give you an image. Okay, so one simple way of understanding a microservice is, microservice will have its own code base and will have its own database. Okay, so this feature gives microservices an advantage to write your microservice in whatever language which you want. So for example, okay, we all understand e-commerce, right? So let me try to open a browser. Good. So this is one of the repository that is basically present or given by Microsoft to understand microservices. So if you see over here, this is a reference application, and we all understand e-commerce. Okay, because somehow we basically use e-commerce. Now this is a microservices architecture. Now what is happening over here is, this application basically has a mobile application, it has a traditional web application, and it has a single page application. Now, and then it has approximately 5 to 6 microservices which are basically running. So if you see over here, there is a order microservice, there is a basket microservice, there is a catalog microservice, there is an identity microservice, and then there are some API gateways, and then there is something, a web application which is an MVC application. Over here, what is happening is, your application is broken down into microservices. And if you look at identity microservice, has its own database, so it has a SQL Server database. Now if you go to basket microservice has a Redis cache. So each microservice has a flexibility on choosing whatever technology which they want to use, that is the best part of it. Okay, and I'm not going to go through all of this architecture, but basically microservice means it will have its own code base and it will have its own database, and a small amount of developers or teams will be working on the individual microservices. So deploying these kind of applications does not come without problems. There are also challenges in basically managing microservices, right? So the advantage of microservices, you can individually deploy it, but there are disadvantages also, or I'll not say disadvantages, I'll say challenges. Okay, and I'm calling it as challenges because we can solve those challenges. Okay, so the challenges are, okay, when something goes wrong, observing interactions between services can be complex. Okay, so when you have too many distributed components, distributed, or you can call it as loosely coupled components, right? So here, what is it I have said? You can individually deploy the service. When you can individually deploy the service, When you can individually deploy the service, sometimes what might happen is, okay, I have a catalog microservice, and then you are trying to deploy a newest version of it, newer version of it. So you might have catalog version v2. So you might not want to basically replace catalog v1 with catalog v2 immediately. You might want to do some kind of testing so that only few customers will basically use catalog v2. Okay, so we might need traffic management at each service endpoint, and this becomes extremely difficult. Endpoint becomes more important. Okay, so that means that you need some kind of specialized routing. Okay, you need routing functionalities. Okay, and then let us assume that in this architecture there are microservices, and each microservice can communicate with other microservice. There might be some cases, or in majority of the cases, these interactions between microservices, you want to have secure communications. You might want to encrypt them. So for encrypting, you might need to write a code in all of your services, which is quite difficult to manage. Okay, so I am just writing securing communication by encrypting the data flows is more complicated. Okay, and in some cases what might happen is, let us assume that we have a catalog microservice, and this catalog microservice is basically requested by mobile applications. On mobile application you click something and then it goes to catalog microservice, and catalog microservice is down. Okay, and there might be a fix. If the user retries, it might work. It might not be a real failure. There might be something, your pod might have restarted or something like that. If you retries the request, then the catalog service might start working, right? Or you might want to give a failure to the user whenever it is taking more time. Okay, so this managing timeouts and communication failures between services can lead to cascading failures. Okay, and it is very difficult to identify which service is working correctly and which service is not working correctly. Okay, right. So these are the challenges which microservices pose. And as I said, for this to understand, you need to know a little bit about Kubernetes. We all know that generally whenever we are deploying these kind of microservices, we create a Docker containers or Docker images out of them, and we deploy it in Kubernetes kind of a system, or a container orchestration kind of a system. Okay, right. So now the whole idea is, developers want to write the business logic, okay, whatever is required for the service to work. And when it comes to these challenges, whatever we have written below, we want some system to take care of it. We want some system to take care of it. Okay, so how all of this started was, I'm quite sure that all of us know Netflix. Okay, so you might have been watching Netflix. Netflix has been basically using microservices from way back. So what Netflix has done is, Netflix has developed some libraries in Java language. Okay, so let me write, I'll just write a simple history. How did we get here? Okay, so Netflix pioneered the development of early frameworks for managing microservices, and they have open sourced as part of Netflix open source software. So you can go over here, and then if you try to use Netflix OSS, sorry, saying this is the Netflix open source center, and they have lot of components that they have made open source. Okay, so this is the GitHub repository of Netflix open source, but I'll be giving you this link. Okay, right. So Netflix, what they have done is they have built components. Okay, components such as, the first component is they have built something called as Asgard. Okay, so this Asgard acts as a control plane. Okay, whenever you are dealing with microservices, it works as a control plane. Okay, and then they have built something called as Eureka, which is service registry. Okay, they have built something like Zool, which is load balancer gateway. Okay, and they have built something called as Ribbon, and there are many other components. I'm just writing few of them. Okay, which is a client side load balancer. Which is a client side load balancer, right? So if you want to take advantage of what Netflix had to build, okay, you had to modify your Java code. This works only with Java. You had to modify your Java application and add these necessary libraries in your code, and then you can take the advantage of basically managing microservices. But in this age of containers, right, we can basically build a microservice in whatever language which you want. Okay, so you might be using Python, you might be using Golang, you might be using .NET or whatever it is, right? So we want to have some kind of a system which basically handles microservices, and abstracts away the specific programming language implementations. Okay, so there was a need for a modern service management system. Okay, and this modern software management system, okay, so as the containers and Kubernetes became popular, the technology for one platform might not solve the purpose. Okay, so these conditions helped to develop the modern service management system, or modern microservice management system. Let me put it in this way. Microservice management system that is commonly referred as, or that is known as service mesh. So am I clear on service mesh, sir? So service mesh is basically, this is the service mesh. Okay, we want to manage the difficulties which microservices pose, and we want to solve them. And to do that, we need something which works on every platform. We don't want something like Asgard, which works with Java itself. Okay, so service mesh. So if I have to define a service mesh, it is very simple. A service mesh is a programmable framework that allows us to observe, secure, and connect microservices. Okay, a service mesh is a programmable framework that allows us to observe, secure, and connect microservices. Okay, so it will have all the policies to govern how microservices interact. Okay, So, and this service mesh should not have, or generally service mesh should not have any kind of programming language uh, specifications, because it should never try to tell that. It should never try to tell that this works only when your language is Java or Python or whatever it is. Okay. So at this point, let us try to basically understand this. Okay. I'll try to draw a very simple kind of communication. Okay. So let us assume that you have your application. Right. Let me write this as, this is web, and this is app, and then this is database. That app you can call it as uh, your application layer or business layer, whatever you call it as. Okay, I have web layer, I have app layer, and then I have a database. Okay, consider each of them to basically look at as if they are your applicational components. Now, whenever any web application wants to communicate with the app, it will communicate directly, right? So this is how your interactions work in your application, right? Now, what happens in the case of service meshes? In service mesh, we will have one component, or let me put it in this way. They will have something called as control plane. They will have something called as control plane. And in each of your application component, they will inject something which is referred as proxy. Okay, so this proxy would be available in all of your applications. Okay, now your web application will not directly interact with app, or your app application will not directly interact with DB. Okay, there is a proxy, and this proxy helps us in adding network policies. Okay, and there is a control plane that manages it. Now let me put it in this way. You have right, sir. Right, sir. So this is something which I would refer as traffic management. Now, when your web wants to communicate with app, basically what happens? Your proxy comes into play, and your proxy, at this proxy you can add whatever policies which you want. Let it be about security, let it be about sending traffic to a particular source, and this is something which we call as service mesh. This is something which we refer as service mesh. Okay, so a service mesh will have a control plane, a proxy, and then it does the traffic management, Okay, So this is what any control plane will have the similar kind of an architecture. Okay. So let us try to look at control plane. What are the different control planes that are available? Okay. Let me save this. Right, sir. So there is for this proxy, there is something called as envoy proxy, which is basically created by uh, Lyft. Okay. So envoy is one of the project that is basically from Cloud Native Computing Foundation, right? So our Istio will basically use this envoy. Okay. So one of the service mesh which we have is Istio. So this Istio was an open source project which was co-founded by IBM and Google and Lyft. Okay. So what Istio does is Istio works very well on Kubernetes, and it helps us to connect, secure and observe your microservices, and it is language agnostic. Okay. So Istio has gone or there are many contributions that are done into Istio from VMware, Cisco and Huawei and all the other companies, and there were a lot of contributions over there. Okay. So Istio is very popular in service mesh at this moment. So in addition to Istio, there is something called as Console Connect. So this is also a service mesh, and this is developed by HashiCorp. I'm quite sure that as part of the course which we learn here at Quality Thought, you might have learned Terraform and Packer. Okay, they are basically developed from the organization called as HashiCorp. So basically, Console Connect is one more service mesh, and then we have one more service mesh which is called as Linkerd. Okay. So this is a open source project, and this is also from Cloud Native Computing Foundation, right? So Linkerd has all the goodies, but okay. So Linkerd is it provides the same capabilities when it comes to service mesh, right? So it is written in Rust language. There are many things. There is something called as app mesh. So this app mesh is not an open source project, but this is developed by Amazon to basically implement service mesh. Okay. So there is one more thing which is called as Aspen mesh. Okay. Okay. So there are many things. Okay. So the reason why we have chosen Istio is because it is popular. There is no other reason around it. Istio is very popular in the service mesh world. Okay. Right, sir. Now, what are the features that Istio will give us? Istio will give us three major features, or the features of Istio can be categorized into three major features. Okay. So the first feature which they give is they give you something called as observability. They give you traffic management. They give you security. Okay. So observability means you can basically understand what is happening in when how your applications are interacting and all of that stuff. Okay. So it gives very rich tracing, very rich monitoring and very rich logging for the services. And when in service mesh, when I refer service, each service means microservice. Okay. So to do that, what it does is it gives you insights by using Grafana. Okay. It gives you Prometheus, it gives you Kylie, and it gives you Jigger for trace flows. And when you basically install Istio, you will get all of this. You will get all of this, right? And then uh, traffic management. So if you go to over here, we have a proxy over here, and this proxy is Envoy proxy, and it is a layer 7 kind of a proxy, and it helps you in traffic shaping. So here you can implement timeouts, here you can implement retries, here you can implement A by B kind of deployments or canary kind of deployments, you will get loads of things. You can also write saying that when I get a request from someone in India, forward it to a particular service. I can do that. Okay. So because we have proxy over here, we can write whatever policies which we want with respect to traffic management in Kubernetes. And then in addition to all of this, it also gives us security features where I can try to tell that any communication between web and app or app and DB should be encrypted. So I need to basically manage security, right? So that can be done by this Kubernetes, this Istio framework. The whole idea over here is Istio is taking away the complexity. Istio is taking away the complexity of this traffic management, and then you as a developer will basically focus on your application, and you develop an application which is HTTP2 communication based. Even if it is one, it works, but if it is two, it works wonderfully. And then you deploy your application as microservices, and rest of the stuff is basically done by Istio. Let us try to look into Istio's architecture. Okay, there is a mistake. Let me launch one more. Right, sir. Right. Now, when we are working with Istio, we have already discussed that there is one important thing that is at the bottom of your, or one important thing which does a lot of things. That is something which we refer as control plane. So you will have control plane. Okay. So as part of that control plane, you would have three major components. Let me do in this fashion. Could be much. And right. So this first component is something which is called as pilot, and then we have something called as galley, and then we have something called as citadel. Okay. And we have a very important component which is called as mixer. Which is basically referred as mixer. Okay. And then right, you will have your Kubernetes application deployed as service. So I'm just drawing two things. Consider it to be your pods. Okay. Pod. Right. So in this pods, okay, you will have a container injected, and that container is something which we are referring as proxy. Okay. And then there will be one more container. Okay. Let me basically go over here. Okay. The best fit. Okay. Consider this container to be your application. Okay. So if you understand Kubernetes, in Kubernetes we can have a pod, and a pod can have multiple containers. Okay, one will become the main car container, the other one will become a sidecar container. So basically what happens is, whenever you are trying to install Istio, in your pods, this proxy will be injected. This proxy will be injected into your pods. Okay. Now we have this pilot, right? What this pilot will do is, this pilot will let me use a black color. This pilot will configure, let me use, this pilot will configure data to proxy. Okay, right. And this citadel will try to, okay, send any encryption related information. So TLS certificates to proxy. Okay, right. So when you look at mixer, any communication that happens from pod, let it be incoming or outgoing, all of that in communication will go through this mixer. So basically at this mixer, what I can do is, I can do two important things. One is I can do policy checks. The other one is I will have telemetry. All the logs that are, all the communication that is happening, I will try to log it. I'll try to log it. And this galley is a component which is responsible for basically interacting with this control plane. So this galley basically speaks with this component. Okay, right? So now whenever your pods are communicating, we can override the networking policy, and then we can try to put whatever kind of communication which we want. So the communication which was happening using Kubernetes now suddenly will be overtaken by this, or overridden by this Istio service mesh, right? So this gives us a lot of flexibilities. So we can encrypt the connections, we can look into how the services are communicating with each other. We can split the network traffic, saying that okay, 80% of the network traffic go to a service with a label called as V1, and 20% of the network traffic send it to a service called as V2. All of these things become possible because we have Istio service mesh. And now whenever your pod wants to communicate to other pod, they will be communicating via proxy. So your pod will overtake the, your pods, the container in the pod will be overtaking. Okay, whenever it sends a network packet, it goes via proxy, and then it will reach to whatever it is. It can be other service, or right. So this is the simplified Istio kind of a image, but as I said, all of this depends on if you understand Kubernetes a little bit, okay, or enough amount of Kubernetes, then it becomes extremely simple for us to understand this configuration. Right, sir? Okay. Now these features are extremely helpful in the case of complicated application deployments. Okay. So as I said, these are the important components. So what we will do is, let us try to just deploy one Istio service mesh. As today we are speaking about introduction to this, let us try to create or install Istio on a Kubernetes cluster. So what I'll do is, I'll try to deploy this on Azure. So let me go to azure.com, portal.azure.com, and first I'll be creating a Linux group. Okay, I'll be creating a resource group where I'll be having a Linux machine. From this Linux machine, I'll be communicating or creating the Kubernetes cluster and all of that stuff. So let me call it as Istio client. Review and create, and then okay. So I have a resource group, and now in this resource group I'll be going with virtual machines, and then I'll be trying to tell that give me one virtual machine, okay, which belongs to Istio client resource group, and let me call it as Qt Istio client, and let me set username and password Qt DevOps, right? Rest of the things I'm not worried at this moment. So let me basically create this virtual machine. Okay. Istio setup. You can set up this Istio on Minikube also, right? Create a Linux VM in Azure. So I'm doing in Azure because it is quick and we can easily basically deploy um, or bring up the Istio client on Azure Kubernetes service. We will be using AKS. Let us wait for this to be launched, and while this is launched, let me install Azure CLI install, because in this machine I need to install Azure CLI. Install the Azure CLI, and I'll be installing it on Ubuntu. Let us see if this machine is up. Okay, so this machine is up, and this is a public IP address. So let me launch the terminal. I'm using Windows Terminal. If you have not installed Windows Terminal, you can do this from Git Bash also, or any SSH client for that matter. SSH Qt DevOps @ right, sir. Now let us try to install Azure CLI. Okay, because I might need some kind of a CLI. This is much easier. I'll be installing Azure CLI with one command. Install Azure CLI VM. I'll give the command. Okay, and also I'll give the link to this page so that if you want to install in a different way, or if you want to install it on a CentOS VM, there are installation instructions for everything. Now after that, execute the following command to login. Execute AZ login. This should not take this much. Right. So we have Azure CLI installed, and let me execute AZ login. Then it says that you go into this URL. So I'm navigating to that URL, and the next thing which it tries to tell is you have to enter the device code, which is this. So let me go over here and enter the device code. Right. And then it will ask for what is your Azure credentials. I am giving my Azure credential over here, and then I should be logged in. So now let us try to see install AKS from Azure CLI. Now let me go to the notes. After successful login, then install AKS cluster. AKS cluster is nothing but a Kubernetes cluster. Okay. Refer here for the documentation. So it is done. Now let me go to this documentation, and then here it tries to tell that if you want to basically create a Kubernetes, you have to basically follow the instructions which are present over here. So let me copy the instruction. Let me create AZ resource group, and these things you can cross check, but in my system they are enabled. Okay. And let me try to create the cluster. The only thing which I'll be changing over here is, here the node count is 1. It means that it runs on only one node. I'm making it as 3 node cluster. This stuff takes a little bit of time because it should set up the Kubernetes cluster. Let us wait for this step to be finished. As I said, this will take time. So this is bringing up the Kubernetes cluster. Good, the cluster is up. Now let us go to this documentation and then let us set up kube control or kubectl. Okay, so I have to execute it with sudo. Sorry. Now once the kube control is set up, I need to get credentials. So yeah, I got the credential. Now let me execute the kubectl command line. Kubectl get nodes. So I have 3 nodes. Okay. So at this moment I'll set up the auto completion for kubectl. So kubectl cheat sheet. So while you learned Kubernetes, I think this is something which you need to basically focus on. Okay, I have given this link in our classes. It makes your life extremely simple. So let me set up this. Let me try to tell source bash rc. Now from this moment, Kubernetes will help me. I can use tab kubectl get pods. So I can use tab. Okay, right. So my Kubernetes is up. Good. So now what we would try to do is let us try to install Istio. And the best part is to install the Istio also. Microsoft has a decent documentation where it basically simplifies it. So now let's try to install Istio. Okay. So for installing Istio, I'll be going through Microsoft's documentation itself. Yeah, right. So since I'm using a Linux client, Istio on Linux. Okay. Istio can be installed in many ways, but here I'll be following the approach which is given by Microsoft documentation. So it is trying to tell me that execute this code. Okay. Now if you see ls, I should be seeing Istio CTL over here. Right. Now after that, I am moving this Istio CTL to the folder that is in path, and then I'm adding the execute permissions. Okay. So at this moment, let us set up auto completion for Istio control also. Just like kubectl, we have Istio CTL. Okay. So we want to set it up permanently. So I'm setting up this. Good. Now, if you want to set up Istio, the first command which you should be executing is Istio control operator init. So let me copy this and let me execute this. Okay, good. So the Istio control is set up. Now kubectl get ns, get namespaces. So are you seeing there is a Istio operator namespace? Now kubectl get all -n Istio operator. So Istio operator has basically created these stuff. Right, sir. Now I have installed the Istio operator, right? So I'm able to see everything. Now let us try to basically execute the next set of commands. So in the next set of commands, it is basically asked to run this. So it is the basic istio-ctl dump. Okay, fine. Let us not worry about it. Let us go to this operator spec, copy this, and then let me try to tell that nano istio dot aks dot yml or yaml, anything is fine. Okay, and now insert your stuff, save this document, and then use cat istio.aks. So this is something which we have copied and pasted. Now kubectl, create the namespace called as istio-system. Okay, and then kubectl apply -f istio-aks.yml. Now kubectl get all from the namespace istio-. So there are some of the things still in so we have to wait till all of these components are up. Okay, sorry, saying there are some of the components which are basically not up yet. So I can basically show you certain things. kubectl get svc, get me some services. Okay, so if you see, there are multiple services. There is something called as Grafana that is added. There is something called as Kylie. There is Prometheus. There is tracing. There is Zipkin. So Kubernetes has a lot of components added which can help us. Right? So if you're running on your local system, you can basically execute commands like istio, ctl, dashboard, and Grafana. If you execute this, it will do port forwarding, and then you should be able to access this. But since you are working on the cloud environments, what I'll try to do is I'll try to expose this service. By executing very simple commands. Okay, so I'm trying to tell that kubectl expose so that we can directly access them. After setup, let's expose. One is Prometheus, Grafana, Kylie, and that these three things should basically solve the problem, at least for now. Okay, so expose service, Prometheus, okay, and then I'm trying to tell that my type is hyphen type is equals to load balancer hyphen name equals to Prometheus ext. I'll call it as ext because it is an external interface, and hyphen namespace, and namespace is istio hyphen. So I'll be exposing three components. Okay, let me write the. Now the next thing is I'll be adding Grafana, and let me call it as Grafana ext. Then the next service which I want to expose over here is I want to expose a service called as Kelly, and I want to call it as. So what this does is this exposes us. Okay, now kubectl get svc hyphen namespace. Where is Prometheus ext? Okay, let me execute all of them and then let me try to wait for the. So let me copy this, right? Right. Now kubectl. Okay. So if you see Grafana ext is pending, Prometheus ext we have some IP address. So let me go over here and it is exposed on 1990 port. Now let me, if I execute http colon slash slash colon 1990. Sorry, saying Prometheus is up. Right. Now let me execute the same stuff. Okay. So Grafana, let me go over here and Grafana works on 3000 port. So let me use colon 3000. Or 30,000. Fine. While this is working, we have one more Kylie ext is pending 20,001. So http colon load balancer is different, sir. Colon 20,001. Let me go back to this. Kylie ext is exposed on a different IP address. Yeah, Kylie is present, Prometheus is present. And now let me go to Grafana. Grafana is exposed on a different IP address. The mistake which I have done was I was trying to use the same IP address of Prometheus. Colon. Sorry, saying we got these components as part of our Istio deployment. Right. So at this moment, what I'll do is I'll try to use the deployment from Istio samples itself. Okay. So GitHub. Okay. If you go to this Istio, you will be seeing something called as samples. And in samples, Istio gives you something called as a book info application. Okay. So we will be trying to run this book info application to basically see how the things work. Okay. So for that reason, I can do this, or you can follow the Microsoft documentation, which I have basically shared with you already. There is it. Okay. So Microsoft, if you go into this, it basically takes an example of Microsoft's own application. Okay. You can use any application. That's fine. Okay. So let me use this book samples because whenever you read any Istio documentations, it is basically mostly explained through this sample books. This is a whole Istio repository, so it is taking time. Okay. So let me get into Istio samples, then cd book info platform cube. And now if you see into this, there are multiple stuffs. If this bookinfo.yaml is a complete book info, right? So then we have book info details version v2, and you can basically have different stuffs over here. So let me not do that. Let me basically execute kubectl apply -f bookinfo.yaml. So it is trying to tell that it has done all of the stuff. So let me execute kubectl get all in my current namespace. So it has created replications, and it has basically created a deployment. So if you want to understand what this book info application is, so Istio book info, if you basically click on this, Istio official documentation tries to describe what this application is all about. So this application has a product page, and this product page has basically 3 versions of reviews which are developed in Java language, because that is how a classic microservice should be. And then there are ratings. So when you go to the product page, you will be getting the details of your application, and you will be getting reviews, and in reviews you will be getting ratings from this Node.js kind of an application. If it is reviews version 1, you will not see stars. If it is version 2, you will be seeing stars in this color. If it is reviews version 3, that you will see stars in this color. So that's basically what this is all about. Now let me see kubectl get all. Good, I think everything is up. Now let me execute kubectl get svc. So right now they have this. Now if you want, you can expose this product page to the outside world. Okay, fine. This is the same Kubernetes application, a classic Kubernetes application. Okay, so now what is happening is a Kubernetes application is running. Now let us try to add Istio functionality. So let me write down that notes. Clone the Istio now cd into samples book info, and then I think we have done platform and cube. Now let's create a book info application without Istio proxies, without Istio. So for that, what is that I have done? I have basically executed a very simple command, which is kubectl apply -f bookinfo.yaml. Okay, then you execute kubectl get all. Okay, wait for all the services to be up. Right, now let's inject, okay, Istio proxies. Okay, so what I'll do is I'll go over here. Okay, let me write down the command over here first. Kubectl apply -f, and then there is a command which is called as istioctl cube inject -f bookinfo.yaml. Let me try to run this command. Right, so now let me execute kubectl get pods -w. If you see, there will be some pods which are terminating and some pods which are creating. Now what Istio is trying to do is, it is trying to remove your pods and then recreate your pods, because as per this architecture, what should happen? Your pod will have a new proxy injected. So for that, what Kubernetes is, what Istio is trying to do is, it is trying to terminate your pods and then inject create a new pod with your application container as well as a proxy container. Okay, so let us see kubectl get pods. Okay, things look okay to me. Okay, so kubectl get svc, right? So now the things are looking good. Okay, so kubectl get svc hyphen namespace istio hyphen system. So in istio hyphen system we have a load balancer over here. We have a load balancer over here, okay, which is at this IP address. Now let me go to this and then let me type http://this/product page. Let us see if something happens. Okay, right. So while it is doing its job, now let me go to the graph of Kylie and then let me tell that I am interested in the namespace which is default. Let me refresh. Okay, namespace is default. Do I have any applications loaded? I should have. Right. Okay, there is one last thing which I need to do. Okay, let me execute kubectl apply -f. In book info itself there will be a folder which is basically called as networking, and in networking let me basically install a gateway. So kubectl get all. Okay, so there should be some of the components which should be applied. Okay, now let me refresh this. In Istio config we have booking info gateway, right? So are you seeing a product page? Now let me refresh this. Okay, so if you see, as I am refreshing I am getting different versions, right? So look at this review. So this is version 1 of review, this is version 2 of review, this is version 3 of review. Okay, if I want I can change all of this behavior. Now let me go to Kylie. Let me basically start it again. Okay, good. Now let me go to graphs. So are you seeing a graph, sir, now? So what it is trying to tell is, when you go to Istio /product page, it will go to product page version 1 latest, and from here it will fetch the details, and in details we have only version 1. Now if you go to the reviews, we have 3 versions: reviews version 1, reviews version 2, and reviews version 3. This is basically the scenario, and reviews version 2 and version 3 are basically getting the ratings from here. So you are basically getting all of this stuff. So if you go to versions, okay, or if you go to workloads, you will be seeing all of this. If you go to services, you will be seeing all of this. And if you go to the Istio config, now in Istio config, what basically you're trying to basically tell is, now I want to basically load balance my load across all of these things evenly, Now let me go into cd dot dot cd dot dot cd networking. And now if you basically look into it, we have used this booking info gateway. Okay, so since we have used that gateway, you have all of this. Now when we start using the other things, we can get all of the other functionalities. Okay, so right now this application is loaded based on these parameters, and then you are able to see all of that in the terms of graphs. And now if you want to see how your individual application behaves, so go into product page, and then you should be able to see that this is the metric and this is the service which you have. What is the traffic that it is coming? What are inbound metrics? Okay, so you get loads of information about your application, loads of information about your application. Okay, now let me go to Grafana. So with Istio, right, there will be a URL over here, right. Now let me go to Istio, and let me just write some information around. Destination service namespace is equals to default. This is a Grafana language, but that's okay. So I think there are different logs that you are able to basically see. Okay, and over here, if you want to see the metrics, 1 minute, operation, diagnostic tools. There is a URL which you need to call. 1 minute, sir. Let me find it out immediately. Okay, let me basically URL. What is this observability? Realizing I forgot that URL. Yeah, /db slash metric dashboard. Now let me go over here and then let me try to tell /dashboard. So are you seeing Grafana is displaying the operations? Now let me basically execute some requests. Okay, and let me go back to Grafana. So are you seeing? It is showing me all the different details about my application that is basically running, what are the TCP workloads and all of that stuff, right? When you run this for a little bit of more time, you will be basically seeing more information about it, but you are able to see all of the information over here. Okay, so now by using Istio, what am I able to do? I am able to basically understand logging of my metrics or logging of my microservices. I am able to configure the microservices. I am able to basically take care of all of the traffic patterns. Now this is just an introduction. Okay, but if you want to understand the whole Istio, there is a long journey which we need to basically go through, so at this moment, okay, for that reason, what is that we are thinking in so we are going to launch this expert Kubernetes. Okay, so expert Kubernetes course will consist of Kubernetes patterns, Kubernetes security and hardening. Okay, we will learn something called as Kubernetes operators. We would learn about Istio, and we would learn about linker D. Okay, right. We will also take a look at Helm in a deeper fashion. So this is one course which we are going to launch in uh, Quality Thought very soon. So in the month of May, in the third week of May, we will be launching this course. And since I cannot cover all of this Kubernetes, this is about becoming an expert or a subject matter expert in Kubernetes, right? But to be part of this course, you should already know Docker, you should know Kubernetes. Okay, so here we will be starting by comparing Docker networking versus Kubernetes networking. Okay, so we will understand the CNI network model. Okay, in the part as part of our course also we do this CNI network model, and then we will try to understand what Istio CNI does. Okay, so this we will be launching very soon. Okay? So if you are interested into getting into hands-on Kubernetes and trying to you want to aspire your career towards expert in Kubernetes, that course should really help. Okay, so that is the whole idea, but this is a brief introduction of Istio. If you know Kubernetes, it would have sound okay, but this Istio is very much important for the organizations who are running microservices, as it is helping them to achieve the things very simply. Developer need not write any code with respect to TLS certificates. Okay, Istio can do it for you. Whenever you are deploying new versions for Canary or A by B kind of testing, it is all about applying a policy. It is all about applying a policy, right? So developers can develop their applications in a easier fashion, and then we can handle all of the networking in Kubernetes by basically using this service mesh, right? So this is what I had, and go through this session once again because it would be on YouTube anyway, right? So the whole idea is becoming an expert in Kubernetes can raise your salary, right? And that is a point why we learn anything, to be efficient with respect to the paychecks which we get. And this expert Kubernetes can help you, and already it is helping some of the people because they have drawn decent packages. Um, this course will cover about developing custom resources also, sir. So it will also have that part. For the people who have finished the course also, there is nothing, because this is altogether as a different course, Sunan. This will be handled differently. Okay, you will be receiving a email from Quality Thought. If you are interested in getting into expert Kubernetes, then you can enroll to this course. Okay, this is different from the classic DevOps course which we have. Yes, Nagabhavan, it covers development also, but it doesn't cover how to write code. It expects you to know a little bit about coding, where we will learn about how to develop custom resources. Okay, so if you are speaking about the certification of certified Kubernetes application developer, that is covered. If you have any questions, you can type in the chat, live chat, sir. So I'll give 5 minutes. Right now it is 9:05. I'll wait till 9:10. You can type your questions and I'll try to answer to that. So I hope there are no further questions. So let me stop it at that, but you can still uh, use this live chat, and I'll be responding even if it is post the course. Whenever you're watching it as a video, we'll address the queries which you have. Okay, but Istio is all about making your life simple. This course will also be taken up by only. Yes, sir. This course will be taken up by me itself, sir. And because if it is someone else who is taking up the course, I would not give the demo for it. Uh, right. CKD is already covered as part of our regular course, Uday. Okay. For becoming CKD or CKAD, you need not do anything special. That is already covered as part of our classic Kubernetes, which is covered as part of our DevOps curriculum. But this is about becoming a subject matter expert in Kubernetes, which is beyond that, right? So the tentative date when this expert Kubernetes will start will be somewhere. Okay, you can take the date as May 17th. Okay, and the timings of this will we have not decided it, but I'm trying to tell you the tentative timings. The tentative timings might be somewhere from okay, somewhere in the time zone of 5 to 7 p.m. IST. Sir, it is not. Istio has nothing to do for developers, sir. Istio has basically, once your developer writes your application, how to control the traffic, how to accommodate changes when new features come. Okay, so there will be some developer workflows which you need to understand, but to learn Istio, you need not be a developer. No, as part of our regular DevOps course, we cover a lot of Kubernetes, sir. But this expert Kubernetes is not in the scope of DevOps. It is beyond DevOps. So that's where it is dealt differently. What does full stack developer have in its course contents? Himakar, I think that will be made. Basically, there is some work that is basically being done, but on an overall note, full stack developer is not the agenda of discussion at this moment. So I would put it in this way. You can just drop a mail to Satish. If he is unable to answer, I'll basically answer the questions. Fee is not yet decided, sir, but it will be nominal for quality thought students. For all of our older students, it will be it will not be more. Okay. Yeah, timings. I think there will be an adjustment in timings, sir, because the timing is not fixed. Yeah. So we will see what will be the best fit timing for. So this is especially for the people who have at least more than 5+ years of experience. If you are a fresher, if you are anything less than 5 years of experience, you need not worry about all of this. Yeah, anywhere from 5 to 15 years of total IT experience, this will help you. If you are anything less than 5, don't even worry about it. You need not know this, at least at this moment. Right, sir. So I'll stop it at that. And if you have any queries, you can contact on comment section below. I'll try to address the concerns which you have. Thank you for joining, sir.